Hi everyone, and welcome to another Unity from Scratch tutorial. This one will be on models. Now we've already seen a number of models because we've been using them in the past tutorials, but I just want to focus on what a model is and what it's made of and how it actually is working behind the scenes. And also we'll cover how to bring models from elsewhere, such as from Maya, or if you've got them from the web somewhere, how to bring those in and deal with any issues that you might get when you bring them into Unity. So first of all, let's just create a cube. So this is a basic model. And if we look at this cube, now I'm using the Alt and left mouse button just to rotate the view. You can see that it's made up of these triangles. Each one of these triangles is a plane, and a plane is a flat surface. So this top part of the cube is made up of these two triangle planes. The triangles are also called polygons because they're polygon in shape. The number of polygons in a model is called the poly count. The poly count is very important because the more polygons you have in a model, the more the computer has to process it, and therefore that will affect the performance of your game. So you want to have low polygon models without compromising the quality of your final product. Now we've already looked at materials and textures, and the way to make really high quality, really nice looking models is to use the texture side of things. Because as we saw, we could have a flat surface, such as the wall, and put really detailed bricks across the wall without adding any geometry because it was all done with textures. Therefore, you only essentially, if we used a cube for that wall, had these two polygons which represented a couple of hundred bricks, which is brilliant. So it's a lot less processing. Okay, so just to recap on moving these models around, we've got the W key. If you hit that, you'll get these axes which allow you to move the model along the axes. And remember the axes of the model, which is the green one for Y, and you can refer to this gizmo up in the top corner again to get a grip on which axes are which. The blue one is the Z, and the red one is the X. When you're designing and moving around in this scene view, I guess it's not really necessary to know which one of these is which when you're moving it because it's kind of intuitive. When we start coding to move these objects around, you will need to have a good grasp on which axes are which and what they're doing. Alright, so when we put a texture onto a model, it fills up these polygons. And we discussed a couple of tutorials about the idea of normals. A normal is a line, it's invisible, but it's stored within the computer with the model. And a normal is a line that comes out of every polygon at 90 degrees. Okay, and the direction that normal is facing is the side on which the texture is put and the side at which lighting, visuality, and those types of things are calculated based on that normal. So there's a number of different models in Unity already built in, such as this cube. If you have a look at your 3D objects, you can see there's a number of other ones here. So we've got a capsule that we can create, which looks like a pill type of shape. There's also a sphere, quads, planes, they're just flat surfaces. So this is our plane. Actually, the plane really demonstrates very well the idea of the normals. So we can see this plane on this side because all of these normals on this are pointing upwards. If we go underneath like this, you can't see it because the plane is a flat surface just made up of all these polys, and because all the normals are on this side, you can't see them when you're underneath. So game objects such as this sphere, capsule, if we go inside it, We're now inside it and we can't see anything because we can't see the inside of it because there is no inside of it. It's all the normals on the outside. Now, just getting back to moving the objects, which I got distracted before. If we select this cube, we can move it around using its axes. Now, as you'll see, everything is moving. Why is that? Why is that cube moving everything? If you have a look in the hierarchy, when the objects were created, they were created as children objects of that cube. That means they're attached to the cube, and therefore they will move when the cube moves. A child object, such as this capsule, if I move that, notice that the plane is attached to it. So the plane will move according to it because it's a child, but the cube will not. The cube is the parent. If we move the cube now, the capsule and the plane will still stay relative to their previous position. If you want to move the plane by itself, like that, you grab it. It's got no children, so nothing else will move with it. Now, the reason these got created and attached to each other is that I had the cube selected when I created the new object. So we don't actually want these things childed to each other. So let's just drag them out and they'll still be in the scene. And now they'll be independent objects. Okay, so moving, we know moving. We press the W key and we can grab this by the axis. We can also grab it by the middle and arbitrarily move it around. Hit the E key to go to the rotation for the object. And you can rotate that around the different axes. Again, the axis that you are rotating around is based on these colours of this gizmo up in the top corner. Then if you want to resize, it's R. And you can grab the axes and resize in that way. You can also grab the middle and resize them all at the same time. Now, these controls work on any models that you bring into Unity, not just the basic ones. Okay, let's have a look at bringing a model from outside of Unity into here. So I'll just go through and delete all of these objects, which might be easier in the hierarchy. Delete that one and that one. Okay, so I went to TurboSquid. That's a great place to find lots of quality 3D models, and you can also find some free ones that you can download and play with. You can also get stuff from the Unity Asset Store as well. The ones from the Asset Store will be more compatible with Unity because they're made for Unity. But I want to show you what might happen if you bring something from outside, such as from TurboSquid, because often those modelers who are working with different software don't build a model specifically for Unity, and sometimes you can end up with a few issues. So I went to TurboSquid and I downloaded a model of a human head, which is the head we used in the previous tutorial. So that model comes in a folder which contains all of the materials and the model files. Try and keep everything together when you bring it into Unity. So if it's in a single folder, drag the whole folder into Unity, because sometimes Unity will find the materials and put them on the model for you. So I've got this face model. I'm going to drag that in. I can just drop it into the project and it will load all of the textures and all of the geometry. While that's loading into Unity, let's just have a look at TurboSquid. The URL is turbosquid.com, and this is the landing page. You can search for models. So I'm thinking I typed head in before when I was looking for the human head, and hit search. Now it will bring up a whole bunch of models, which will be ranged from free to quite expensive. If you're looking for stuff just to play around with for your own use, such as I am here, you can sort by the lowest prices, and it will then order these with the free ones up the front. So this is the face model that I've downloaded and I've been using. You can't use all models in Unity. they're not compatible. So there's a whole bunch of different formats that models get saved in. You can see that this face one, if you look down here underneath it, in all of them for that matter, it tells you the file formats that you can grab the model in. So this is 3ds, there's also a max file and an obj file. 3ds and max are files that are created by 3ds Max software. Okay, these are not compatible with Unity. 3ds, I believe, if you do have 3ds Studio Max installed on your machine, does work. I don't tend to use these files. Max you can't bring straight into Unity, but an OBJ file format is compatible with Unity. It's just a basic model format, has no animation or anything, but it is a still model with textures on it. The native file format that is used by Unity is an FBX file. And if we have a look at this model here, you can see, if you squint maybe on this video, it has FBX as one of the options. So where possible, try to get a model in FBX format. If you can't, OBJ will work. But remember, OBJ does not have animations. FBX, if the model is animated, will contain animation data as well. Okay, our face should now be loaded into Unity. So it's in this directory here. It's an OBJ file. If we open up that folder, we can see all of the different textures, and we can also see the OBJ model file. To bring that into the scene, we can just drag and drop it in. It's actually quite a large model. And if I rotate around this to get to the front, okay, so it hasn't brought in the textures with it. We're just getting the model. Sometimes you'll drag in the model and it will bring the textures in automatically. I actually think this head's too skinny. I just want to make him a bit fatter. There we go. Okay, now if we have a close-up look at this model, you can see that it's made with a whole bunch of triangles. Okay, so these are the polys of this model. Now, if I switch to Maya, which I've opened up this model in, you'll be able to see those polygons a lot clearer. So here's our head. If I click on it, you can see those triangles that make up this model. A lot of models do come with squares that they've been created with. If you create something in Maya, if I just rotate like this, and I'll add a quick cube, then this cube is created with squares, and I can modify those so you can see them. If I change these subdivisions in here, you'll see that's squared aligned. Now you can in Maya change this to a triangulated model before you bring it into Unity, but that's not the purpose of this exercise, so I'll just delete that square. Let's go back to this head model and have a look at these polygons. Okay, now I talked about normals before. We can see the normals in Maya by displaying them. So under display polygons face normals, if we turn that on, he'll look very hairy. But if you have a close look at all of these, you can see the normals. It shows you where they're sticking out, especially around the nose here. Okay, so these are all the normals for all of these planes. They're sticking outwards, so that's good. That's what you want, so that when you put textures and that on your model, you can see it. But what's going to happen if I select some of this nose? Let's go into face mode, and I will select this nose, and I can flip the normals so that they're now inside the face. You can't see them on the outside because they're actually pointing inwards. Then if I save that and bring it into Unity, you're going to see the effect. So I did that before, and let's just flip back to Unity. So here's our face model, our normal face model. I mean, it's our original face model. We can now create some materials. I can drop the face diffuse map straight onto this face, and it will automatically create a shader for you, a material, which is essentially called a shader in other words. Okay, now his eyes look a bit odd because they're separate objects, so you can grab an eye and drag that onto there if you don't like these sort of dead zombie eyes. Okay, so here's our face, and if we go inside that face, you notice you can't see the back of the head. It's pretty creepy that you can actually see the eyeballs from inside, but because there's no normals on here, you can't see that when you're inside the head. So what happens with our model that we created that has the nose inverted? If I bring that in from outside, just drop it into here. I saved it as an FBX file just for convenience and for compatibility. And let's see, that's face 2. Bring face 2 in, and let's just size that up. And let's have a look at this nose. You can notice it's missing. You can, if you turn the head around, you can see the inside part of the nose, but you can't see the part that's on the outside. And that's where all of those normals were turned inside out. Now, why am I showing you this? Well, sometimes you can get a model from elsewhere and bring it in, and part of it will appear to be missing. The reason being is that the normals of that part of the model are flipped around the wrong way to be used in Unity. So you need to take it into a 3D modeling package and reverse those normals if you know how to do that. If you don't, you need to find another model. It's as simple as that. So when we now put textures onto this guy's face, it won't texture the outside of the nose, because essentially there is no outside of the nose, but there's an inside of the nose. So if we just move this over here, you can see that inside, and it just looks weird, doesn't it? Now, the last thing I'd like to cover for the end of this tutorial is the number of polygons that is being drawn. The number of polygons being drawn is going to affect the performance of your game. So I've loaded in a model here of Tower Bridge, and if we switch to the game view, you can see what the camera is looking at. What I've done is turned on this little statistics box, and you can turn that on and off up here. It shows you how many triangles are being drawn. So this is the number of polys being drawn. This model has 18.4 thousand triangles in it. So they're being drawn as long as the camera can see them. Now, the camera we looked at previously, this particular perspective camera, is the shape of a pyramid. Okay, so it's got a square flat bottom, and it comes to almost a point. It's quite flat at the top. It's not a perfect point. This is the camera's viewing volume. Anything that falls inside the camera's viewing volume is going to contribute to this number of polygons. Now, the camera itself, you can adjust the size of its viewing volume with, if we look at these clipping planes, you have a front clipping plane, which is the near, and you have a far clipping plane. If I just go back to this scene view, and if I can get closer to that camera for you, you can see the near clipping plane, which is this flat plane here, and I can adjust that by increasing this, and you'll see it change there. Okay, so this is called the camera's frustum, which is the viewing volume of a perspective camera. We'll look at orthographic cameras a little later. Now, the far clipping plane is important because it's the one right at the back. If you're in a scene and you can't see that far, if your character can't see right to the back of the scene, then there's no need to have your clipping plane out that far. If I switch back to the game view, what I'm going to do is just change this far clipping plane and bring it closer to the camera. As I do that, you'll notice that the model starts to disappear because it's no longer in view. But what's happening to our triangle count is that there's still 18.4 thousand polygons being processed. This model is a complete model. It's all joined together into one single object, which means that even if the smallest little snippet of that model is inside that camera's viewing volume, the whole lot still needs to be processed. So what is this telling us? Well, it's telling us that if you have a really large model, so say it's your entire scene, it's a castle or some building that your character is running around in, you don't want it as an entire model because it's just going to be drawn all of the time. It's going to be processed even though it's not being seen. You need to split it up into smaller pieces. So let's just replace this model with a whole bunch of cubes just to demonstrate what's going on. So if I just add some cubes, and let's pretend this is another tower model, put this here, and then I'm going to duplicate it and put a whole bunch of them like this. Okay, then I'm going to set the camera to look at them. So from, let's say, this point of view. Okay, so we select the camera and we align with view. Okay, now this camera has a very short far plane that we set before. This is why you can't see them. But if we switch back to the game view and we now start increasing that to bring them in, you can see that as more and more are added, it's probably too small for you to see on this video, but you can try this for yourself. As more and more get drawn into that view, the number of triangle counts go up. And then we draw back and again it'll go down. Because they're all separate objects, it means that they're not all being processed, even though they're in the scene, but they're not inside of the camera's viewing volume, they're not processed. So that's why large models should be split up into smaller sections. Okay, well, that's it for this tutorial. I hope you learnt something useful. Always keep in mind normals. Always keep in mind the poly count of objects, especially if you're going to be creating for mobile games. Even though devices are getting more powerful, they're never going to be as powerful as a full-on desktop gaming machine. So you need to be thinking about dialing back those polygons and having low poly models. And if you have a look in the Asset Store or TurboSquid or maybe 3D Cafe online for third-party models, you can do a search for low poly. Okay, thanks for listening, and I'll see you in the next tutorial.